Hi everyone. Today I'll look at two reactions and we're going to be able to analyze them to talk about oxidation and reduction, reducing agents, and oxidizing agents. The first reaction is a net ionic equation with zinc ions reacting with calcium atoms to produce zinc atoms and calcium ions. Let's analyze this reaction. The zinc ions were two positive and turned into zinc atoms that are neutral. From positive to neutral, that's a gain of electrons. Because electrons are negatively charged, if something that was positive gains negative charge, it becomes neutral. So we can say that these zinc ions gained electrons. Now, a gain of electrons is reduction. So we can further say that these zinc ions were reduced. Finally, the substance that is reduced we call the oxidizing agent. So these zinc ions are the oxidizing agent. I'm going to go ahead and label that here as the OA. By a process of elimination, all the opposite things must have been happening with the calcium. However, we can reflect in detail about it. We have these neutral calcium atoms becoming positively charged calcium ions. It was neutral, became positive. Once more, because electrons are negatively charged, if we give some away, a neutral substance will take on a positive characteristic. This means that the calcium lost electrons. And a loss of electrons is oxidation. So, the calcium was oxidized. The substance that undergoes oxidation we call the reducing agent. Calcium is the reducing agent, which we can label as the Ra. It's a handy rule of thumb to keep into our back pocket that positive ions are, with only a few exceptions, oxidizing agents, and solid metal atoms, with no exceptions, are reducing agents. We can use Leo says Ger and our knowledge of oxidation and reduction to get down into the details of a net ionic equation in order to talk about which substance lost and gained electrons, which one was reduced or oxidized, and to label the oxidizing agent and the reducing agent. The second example is not a net ionic equation, it's a traditional single replacement reaction. Here, there's one thing to keep in mind before we begin this process, and it's that compounds are formed by ions. So when I see these hydrogen bromides here, I can realize that that means hydrogen ions, which I happen to know are 1 plus, and bromide ions, which are 1 minus. So I have solid strontium atoms reacting with hydrogen ions and bromide ions to produce strontium bromide, which is aqueous strontium ions and bromide ions, and hydrogen gas. So, when I look at the strontium, I see that it's atomic. Strontium atoms, which are neutral, became involved in this compound. Because compounds are formed by ions, indirectly here, it's hiding in there a little bit, that's telling me those are strontium ions. The neutral atom it actually is a positively charged atom. To go from neutral to positive, we must have lost electrons. Here, the strontium lost electrons. Because the strontium lost electrons, it was oxidized. And the substance that is oxidized is the reducing agent. As we saw in the previous example, and it's a good thing to keep in the back of our mind that metal atoms, a solid calcium atom, that's a metal atom, solid strontium atom, metal atoms, with no exception, if they're participating in a redox reaction, are going to be reducing agents. We have to look a little bit closer here now. It's not as simple as a process of elimination. These hydrogen ions became H2 gas. The bromine ions are still in a compound. The bromine ions did not change. They're in a compound before, as ions. They're in a compound after the arrow, again, as ions. So it's the hydrogen that actually underwent some change. It's hydrogen ions, positively charged ions, became neutral hydrogen atoms. The H plus here gained electrons. To go from positive to neutral, that requires a gain of electrons. And a gain of electrons is reduction. H plus was reduced. And the substance that is reduced we call the oxidizing agent. The hydrogens here were the oxidizing agent. When we're labeling oxidizing and reducing agents, it's also worth noting that we can only apply those labels to the reactants. We're never going to put anything on the product side in terms of labeling oxidizing or reducing agents. The final thing that we could possibly say about this second example is, what was going on with the bromines? Here's bromine in a compound, it's as an ion. Here it's still in a compound as an ion. The bromine was an ion before and after the reaction. It didn't change. So we could call it a spectator ion. So if we have net ionic equations or traditional single replacement reactions, we can analyze them to talk about which chemical was gaining or losing electrons, which chemical was oxidized or reduced, which chemical was the reducing agent or the oxidizing agent, and when we have a single replacement reaction, we might even be able to identify what the spectator ion